Now we have just more examples. So let's take this r to the negative fifth over r to the negative 2. Do it using rule 2 and also using rule 7. And then same for the AB example. Pause the video and then come back and see how you do. Okay, using rule 2 just tells me to subtract my exponents if I have a common base. So I'd have r to the negative 5 minus a negative 2. Again, just be careful with your negatives, which would be r to the negative 5 plus 2, r to the negative 3, and I'd want to leave my final answer as 1 over r to the third. Now if I used rule 7 says that rather than subtracting, I'm going to move things around. R to the negative 5 tells me that he wants to go to the denominator. R to the negative 2 tells me he wants to go to the numerator. So they can move, but when they move, they use up their negative sign. So this just becomes r to the 2 over r to the 5. Now I need to simplify, so I'm going to subtract, but who has more? Is it top heavy or bottom heavy? It's bottom heavy, so I'll take r to the 5 minus 2 and get 1 over r cubed. Again, no matter how you do it, it's going to work. You just need to make sure that you're not making up mysterious fictional rules. Okay, next one. Rule 2 and Rule 7. So look at the A's and the B's. Are there more A's on the top or the bottom? Definitely more on the bottom. So when we do Rule 2, we'll take 3 minus a negative 1 for the A exponent. And there's more B's on the bottom as well, so we'll have 8 minus 2 for the B exponent. Again, if you wanted to do standard Rule 2, that would be absolutely fine. I just didn't want to do this example 3 ways. 2 ways is plenty. Okay, this would give me a to the 3 plus 1, or 1 over a to the 4th, b to the 6th. Now Rule 7 says that rather than just subtracting when I see my negatives, I'm going to move them. So a to the negative 1 would just come down to the bottom, and then I just combine like normal, and I get exactly the same answer. 1 over a to the 4th, b to the 6th. Pause the video and make sure those make perfect crystal clear sense before you go on. Or send me an email or a text if you have any questions. Or post a thing on YouTube, that'd be great too. Okay. Here we've got another one. We've got more than one variable involved again, along with some numbers. So my negative 8, y to the negative 2, 2 times y to the 16th, z to the negative 2. Again, I could use a rule 7 right off the bat. That would be absolutely fine. I am just going to use rule 1 though. So that gives me negative 16, y to the negative 12 plus 16, which would give me y to the 4th. The negative 16 stays the same, the z to the negative 2 stays the same. Now I cannot leave my answer like this. What is wrong with this one right here? I'll give you a hint. The negative 16 is just fine. It's the z to the negative 2. What does that negative 2 have power over? It only has power over the z, so the z is the only thing that moves. The negative 16 is just fine. That is just a negative number. That's not a negative exponent. So make sure that you see the difference. So note only the z moved. And also note the negative on the 16 is not an exponent. It's not going to move it around. Okay, another example. So if we have negative 4c to the 12th, d to the 7th. Again, there are so many different ways you could start this. It really doesn't matter which one you do first. I'm just going to start by using Rule 4. So look at Rule 4 and see what I will do. Good. Okay, I'm going to give that exponent to everybody in there. Negative 4 gets squared, c to the 12th gets squared, d to the 7th gets squared. Then I'm going to give that negative 1 to everybody there. 5 to the negative 1, c to the negative 3 to the negative 1, d to the 10th to the negative 1. Negative 4 squared is 16. C to the 12th squared is c to the 24th. D to the 7th squared is 14. So just power raised to a power. I'm just using Rule 3 here. Okay, now I could do a few things. I'm going to use a Rule 7 to move my 5 and my d to the negative 10. And then I'm going to use Rule 2 on the c's. Take a look at that and make sure it makes sense. I'm using Rule 2 on the c's and Rule 7 on the 5 and the d. So the 5 came up and he used up his negative. The d to the negative 10th came up and he used up his negative. then c to the 24 minus 3. So I get 80, c to the 21st, d to the 24th. Maybe we're doing too many examples, but I don't think too many can hurt. You just don't need to watch the ones you don't want to. All right, one more. Now this one I'm going to show you a shortcut partway through. First of all, let's simplify the inside. Is there anything I can do to simplify that? Well, I've got 5 on the top and 10 on the bottom. They're both divisible by 5, so that would cancel the 5 on the top and leave me with 2 on the bottom. All right, c is going to have to just stay where it is. How about that d to the negative 3? Again, two ways of thinking of it, a rule 7 or a rule 2. Either will be fine. Either will get you to c over 2d to the 8th. All right, now what do? I am going to do a combination of rule 4 and 5 here, and then I will show you a shortcut of how to get around it. So that exponent's outside, it has to be given to everybody. So it's c to the negative 1, 2 to the negative 1, d to the negative 8. Now with all those negative exponents are telling me that they want to change places. So everybody changes places, so we have 2d to the 8th over c, and I'm done. Now if we back up just a little bit, let's go back to the center. We have c over 2d to the 8th, all to the negative 1. If all of that is to the negative 1, it's telling me everybody wants to change places, so I can just flip the fraction. Same thing. So that's that example. And here is our very last set of examples before we do scientific notation. These ones are probably the easiest to do, but they're the ones that throw people off. I don't know why they do. Well, I do know why they do. It's because all of a sudden, if you go back and look at all the examples you've already done, all of them only had one term. Remember what a term is. A term is stuff that's glued together with multiplication and division. The second you have addition and subtraction signs in the middle of your expression, you're separating it into different terms. I think it's because these are separated into different terms and you're just not used to it that they get thrown off. So when we think of this is 5 to the negative 1. That tells me 5 wants to go to the denominator of its term. But then I have plus 2 to the negative 2. That 2 goes to the denominator of its term. Those are different terms. They are not part of the same fraction. So what that does is it's 1 over 5 plus, I have to maintain these separate terms, 1 over 2 squared. Those are not part of the same fraction. I hope that makes sense. Okay, then my 1 over 2 squared would be 1/4. What do I do with these? Oh, we're just back to lecture 1. We get to do common denominators again. So we do 4/20 plus 5/20 gives me 9/20. Now look at this one. Before you even start, how many terms are there? Good, there's just 2 terms. That plus sign separates this into 2 terms. So the 5 and 2 to the negative 3, they're all part of the same term. They're joined together with multiplication. So that 2 to the negative 3 wants to move. The 5 isn't going to move, but the 2 is going to move. Similarly, the 4 needs to move, but the 2 doesn't move on the next one. And note these are different terms. They are not part of the same fraction. They are separated by that plus sign. So I get 5/8 plus 2/4. My common denominator would be 8. And I get 9/8 for my answer. And that is the last example of our working with exponent rules. We'll then do scientific notation and then move on to polynomials the next time, which is fun. Let me know if you have any questions at all.